Hello everyone, this is Team 5. Our target paper is traversable ground and above ground object segmentation using graph representation of 3D LiDAR scans, and we will give a presentation about our progress so far. From previous presentations feedbacks, we added theoretical background details and reasons for using travel as a baseline. And finally, for our progress, first, configuration and calibration of sensors to create an algorithm that can work robustly in various LiDAR sensors. Second, fusion of SLAM and travel algorithm to fuse historical information. Finally, introduction of traversable mapping algorithm and LiDAR IMU autometry algorithm that we want to utilize. The reason why we use travel for a baseline is to perform the ground and object segmentation, which is robust to environment. Travel has a possibility of traversable terrain and does not use ring label of LiDAR data. Also, travel algorithm is easy to integrate with other frameworks such as QGIS and AOS, and it has a wide application range like local terrain mapping and global traversable mapping.
I'm Myung-woo Jung, and I will introduce about the theoretical background. First is traversable terrain modeling, which is the main contribution of travel algorithm. We use PCA-based terrain modeling similar with these two papers, and this is our framework of terrain modeling. First of all, select the initial seed based on the height of each point, and then we do the planar modeling by adapting the singular value decomposition on the covariance matrix of the point distribution. Next, we use the inlier of the model as a seed for the next step and fit the terrain model by following this process recursively. From the process that I mentioned before, each node consequently has the information of the planar model. After that, we calculate the weight of each terrain based on the eigenvalues. This weight is utilized as an indicator for check whether the terrain is modeled correctly or not. Next theoretical background is for calculating the traversability between each terrain model and the final terrain modeling. The traversability between each node is decided by the function here, and discontinuity of the model and the similarity of the normal vectors are utilized for the function. After then, the overall planar model is re-estimated based on the nodes that contain the traversable terrain model using this function. And this function re-estimate the planar model through the weighted average step, which based on the weight
I'm Mino, and I will share our current progress. And first of all, our improvement plan is as follows. And there are mainly two and three in detail. First one is to overcome the sparsity of the LiDAR data. We use the historical information. And second, apply our method to legged robot navigation. And lastly, make it to be robust to sensor model. Firstly, we prepare two big different type of sensor module. One module configuration is here. This module for configuration is in here, and this module configuration is in here. One module use the outer LiDAR and with the camera real sense camera and Xsense IMU. And the other one includes the LIOS Avia LiDAR and rear sense camera, and IMU GPS. And the calibration result is in here. And the calibration result is calculated by the algorithm which is proposed in this paper. Robust real-time LiDAR initialization proceeded at iROS 22. And to utilize the historical information of the scan data, we integrate travel algorithm to LiDAR-based SLAM. This is the integrated framework we changed in this part and this part. And this video is the mapping result of our improved framework. This is the result of the global mapping based on our improved odometry result, and this one is traversable mapping based on the global map. These results are the odometry result of the original LiDAR SLAM and our improved LiDAR SLAM. When estimating the odometry result without loop closure, there is some performance improvement. So by considering traversability in ground segmentation, the odometry can be estimated more accurately. We can check this part and this part. In the previous page, it can be seen that using travel algorithm for odometry estimation give slightly better result. And to make better odometry and historical information, we will use IMU data on the odometry algorithm. This video is the result of this paper, FastTrio 2, and it is an odometry extraction method using LiDAR and IMU. Okay, skip this video. This paper is a study applying the traversable mapping method to LiDAR odometry. As such, it shows some reliable results at outdoor, like this video. But in this result show that this algorithm can not be applied to the indoor navigation. We are analyzing this region to overcome this problem as well. And in the next presentation, we will show our own traversable mapping results. Thank you for listening.